Good morning to all. In last video, we discussed about different types of pressure control valve and flow control valve. So in continuation to that video, today we are going to deal about different types of flow control valve, that is non-return type valve, and how the non-return type valve will create a functions like under operation and R operation in pneumatic circuits. And after that we will go with a simple direct flow control and indirect flow control by using single acting and double acting cylinder. First we will go with a recap. So I just go with what we discussed in last videos. So in last video we discussed about different types of pressure control valves and how the pressure limit valve is used and how the pressure regulator valve is used in our pneumatic and hydraulic application, and how the safety purpose can be withstand by using the pressure control valves. And then we will go with the flow control. In flow control we are having different types of non-return valves. That classification we discussed, and after that we discussed about a check valve, and then we will go with some symbolic diagrams, and with the help of activity we completed and how the symbols can be represented in simulation tool. And after that we will go with some demo videos for check valve and pressure control valve. By that we will go with today's topic, and in this the non-return valves are used for special purpose valves, where the shuttle valve and quick exhaust valve will be our today's video topic. So first we will go with the shuttle valve. As similar to your check valve, in our shuttle valve you just see the pneumatic symbol. The shuttle valve will also have a ball arrangement which is similar to a circular poppet arrangement. It can either close this path, that is pilot, or it can able to move here and there, and it can able to close this path. So whenever it is a 3/2, whenever the flow will be from P1, what happens here is this ball will go and block the P2. So the path towards the P2 will get closed, so that the P1 inlet is connected with our accumulator or output through A port. Suppose if I am going to give input through the P2, what happens here is the ball will move from here in this initial position, and it is going to close the P1 port, so that the path for the P2 connected towards the A will be happen. So that by using a shuttle valve you can able to either close any one port, input port, which is connected with your output can be done. And there will be another one valve called quick exhaust valve, which is similar to your shuttle valve. The only advantage is the shuttle valve will be connected with one external vent, or it may be connected with a silencer. So what is the purpose of using this type of quick exhaust valve is, in our applications we can able to use this type of quick exhaust valve, and you can able to release the unpressured or unwanted air from your cylinder or from your actuator directly sent through this valve, or it cannot able to wait for until the valve connection is closed with your DCB. So in between any intermediate position you can able to use this shuttle valve to send out the unpressured air by this silencer, or it may be an external vent. So this will be another one advantage, where you can able to release the unwanted or unpressured air, and at once in that particular circuit itself you can able to use this type of quick exhaust valve. So these are all the simple non-return type special purpose valves which we are using in our day-to-day life pneumatic circuits in industries. So by that I will wind up the types of valves. I directly go with an applications or simple circuits where we can able to use these types of valves in our pneumatic circuits. So I just go with non-return valve function. So commonly your shuttle valve will be used to make your simple operation or simple or function in your pneumatic circuit. So we already know in our analog electronics, R operation or R gate operation will be if either any one input, we are having two input switches or we are having two input channels, if any one input is turned on, your output will get excited, or if both the input will be turned on, your output will get excited. So that function can be performed in our pneumatics also. I just go with a power source which is a compressor, and I am having two input which is a manual operated push button. So switch 1 and switch 2, both the output of your switches, that is 3x2 valves, are connected with your shuttle valve. So this will be an P1 and this will be an P2. So whenever the push button switch 1 is pressed, what happens? This input will be flowing through your shuttle valve. Or if you are pressing this push button, what happens? Through this channel, your input will be flowing. So at this position, I am going to press this push button through the switch 2. What happens? The input will be flowing through this. So the ball will move and close the switch 1 port, so that the input will flow from switch 2 and it is going through your one-way flow control valve, so that you can able to control the flow by using this variation, and it is going to actuate your single acting cylinder. So this will be a simple R function. If switch 2 is turned on, output will be excited. If switch 1 is turned on, output will be excited. If both the switches are turned on, so output will get excited. So by using this shuttle and a one-way flow control, you can able to do the R function in our single acting cylinder. So by that, we will go with another one function, that is AND function. Without any shuttle valve, the AND function will be, you know that in our analog electronics, if both the input will be in on condition, then only the output will be on. So both the switches or both the input will be connected in series, such that if switch 1 and switch 2, both the switches are turned on, then only your single acting cylinder will get actuated. So to do this operation in our fluid sim, I just go with a deturn type push button instead of normal push button, so that I can able to hold the position where I give force. So by this you can able to do the AND operation or AND function in your pneumatic circuits. So in later videos we will discuss about how the fluid simulation circuits can be developed. So in this video we are just understanding the working and principle of how the R function and AND function is happened by using a normal flow control and non-return valves. So I just go with the next slide. So here we are going to discuss about the direct control or flow control operation by simple circuits, that is simple pneumatic circuits. So first I will go with a double acting cylinder flow control by using an AND operation, where I can able to use two switches, so that I can able to control the two direction flow, because in double acting cylinder we can able to control both forward and reverse direction. So I just using a two manual switches in forward motion for switch 1 and retracted position to obtained by using a switch 2. And here the flow can be controlled by using an one-way flow control valves. So in this circuit, the 5x2 pilot operated valve will acting as a direction control valve. It can able to create a direction where the output double acting cylinder will obtain an input from your compressor. So you just see in your right hand side, the input will be 0 when I press either switch 1 or switch 2. What actually happens? So since in initial your double acting cylinder will be in initial 0th position, so I have to going to press the switch 1 first operation. So if I am pressing the switch 1, your input, that is cylinder, will move from 0th position to maximum 100 mm. And once it reach this position, if I am releasing and if I am going to press the switch 2, automatically it comes back to its retracted position and it is reaching the 0th position. So this will be the actuation of your double acting cylinder, and this type of controlling the circuit is said to be a direct flow control of double acting cylinder. Then we will go with the next one. Without using any external 3x2, within our 5x2 DCV, I can able to introduce a push button, so that I can able to do manual operation within the direction control valve to control the flow operation by using one single one-way flow control valve. So in this same, you are reducing the hardware component from 3 valves into one single valve, and you can able to achieve the same output operation which happened in our previous circuit. So by that I will go with the next one, direct flow control of double acting cylinder by using an 4x2. So as we are doing in 5x2, we can able to do the same operation by using an 4x2 DCV. So when you are using an 4x2 DCV, you can able to reduce the circuit cost, and overall at low cost you can able to achieve the same output application. So at the same time you can able to do the same operation automatically. How you are going to do it, the same circuit in automatic means you are going to introduce an output circuit. You have to introduce either mechanical switch or either electronic sensors, which is going to sense the initial and final position of your cylinder piston head. So that, for example, here I am going to use an distance ruler and I am going to mention A1 and A2. A1 mentions the 0 mm position of your cylinder and A2 defines the 100 mm position of your cylinder. So the maximum extraction of this double acting cylinder will be 100 mm. So the A2 defines the maximum. So if I am defining A1 and A2 as like this, I can able to predict the position of my double acting cylinder piston head. So with the help of that, I can able to trigger the DCV valve by selecting the 5x2 pilot actuated DCV, and I am going to use the limit switch mechanical actuated roller switch as a sensor. When the initial piston head reaches the A1, the output of your sensor is connected with your 5x2 forward actuation, so that whenever the A1 is initiated, your 5x2 DCV valve will forward the double acting cylinder, so it is going to move forward. At the same time, when it is moved forward and reaches the 100 mm position where it is going to sense the A2, at that time the A2 roller will get energized, so the output of your A2 will excited the retracted position of your 5x2 DCV, so that your double acting cylinder will return back to its initial position. So this actuation will be done automatically once you turn on your compressor. So this type of operation will said to be a mechanical actuated fully automated circuit. In normal pneumatic circuit without any electrical intervention, you can able to do the fully automated by introducing these type of mechanical sensors. Either it will be a limit switch, or it will be a roller type switch, or it will be a bend roller type switch, whatever it will be. By that you can able to achieve the fully automated circuit. And in applications, I just go with an applications in later video, and as of now I will complete it here, and I just recap. These are all the things we discussed in our simple video. Thank you.